voice. It's my pleasure to be the moderator today, and I'm from the UQ School of Business and the Center for Policy Futures. And if you bear with me for one moment. I would like to begin by acknowledging the traditional owners of the land on which we meet today. I'm here in Brisbane, so that is the Yagara and Turrbal peoples. And I would like to pay my respects to their elders, past, present, and emerging, and recognize their long and continuous connection to country. This afternoon's topic is deep learning. And this is your chance to ask all of your burning questions about deep learning, from the technical and applied side to even ethical and social questions. And we have gotten a number of really great questions from you guys already. So I know we're going to have a fascinating conversation. The Ask Me Anything series is brought to you by the UQ AI Collaboratory. And you can learn more about who we are and what we do here at this website. And the idea of these events really is to raise awareness about all the fantastic artificial intelligence research that's happening here at the University of Queensland, and look at that from multiple perspectives and create new connections and collaborations. And we'll be continuing to Ask Me Anything about AI conversations throughout the year, about once a month, and they cover various topics in the field of artificial intelligence. Just to give a plug, we have an upcoming Ask Me Anything session happening in August that I think you won't want to miss, with Vishal Sikka, the founder and CEO of BNI Systems, which is a startup company in the San Francisco area. And he was formerly the CEO and managing director of Infosys and a former member of the executive board of SAP. And we will follow up as that gets scheduled with an email about that if you're interested, and all the other fantastic activities with the UQ AI Collaboratory that are planned for this year, including our seminar series. And if you have topics that you would like us to cover in the Ask Me Anything series, please send an email and reach out. We would love to hear from you. So just to give you a sense of how our session is going to work today, our session is 60 minutes. And if I could just ask that everybody put your microphones on mute and keep them on mute throughout the session, but please feel free to ask your questions in the chat. So we will start off our session with your questions that were pre-submitted. And we will try to get through as many of those as possible because they were really great questions. I'm going to be learning right along with you from our experts. And then in the final 15 minutes or 20 minutes or so, I'll open it up to the questions that you put down in the chat. So please, if you think of questions as we go, jot them down into the chat and we will do our best to get to them at the end. So to start off, I would like to introduce our panel. And we are so incredibly lucky to have this panel with us today. I will give everyone a brief introduction, but I'd also like to extend my apologies in advance because this is an amazing panel and I know that I won't be able to do them justice. So if you haven't already, please go to their websites so that you can check out their amazing work. First, it's my pleasure to introduce Jeremy Howard. Jeremy's a data scientist, researcher, developer, educator, and entrepreneur. Jeremy, as many of you probably know, is a founding researcher at Fast AI, which is a research institute dedicated to making deep learning more accessible. And we are so lucky because he is also now an honorary professor here at the University of Queensland. Before that, Jeremy was a distinguished research scientist at the University of San Francisco, where he was the founding chair of the Wicklow AI and Medical Research Initiative. And he was also the founding CEO of...
Sorry, Caitlin, I'm not sure if it's just me, but I'm getting a lot of static. Is anyone else getting static? My audio is fine. So apologies.
Oh. Alina says my audio is fine. Anyone else? I'm not getting static.
I'm not getting static either.
Okay. Thanks for the feedback. I'll keep going. Sorry, Shakes. Enlytic. Jeremy was also the founding CEO of Enlytic, which is the first company to apply deep learning to medicine. And 2 years in a row, it was selected as one of the world's top 50 smartest companies by MIT Technology Review. And also just wanted to plug his TED Talk, The Wonderful and Terrifying Implications of Computers That Can Learn, which is already, can you hear me? Which has already had over 2.5 million views. So if you have not already checked that out, you probably want to. Welcome, Jeremy. It's also my pleasure to introduce Dr. Alina Shakes, I think. Oh, okay. Just looking at the chat here. It's also my pleasure to introduce Dr. Alina Bielkowski, who is a computer vision and machine learning researcher here at the University of Queensland, developing interpretable machine learning models to increase the performance and transparency of AI decision-making. Her research looks at quantifying and extracting actionable knowledge from data to solve real-world problems and support human understanding of AI models through feature visualization and attribution methods. And she's applied these techniques to various applications from medical imaging and modeling human attention in driving to intelligence surveillance and sports analytics. And in addition to all her amazing academic outputs, her work has resulted in 6 international patents filed with Disney Research, Toyota Motor Europe, University College London, and the University of Queensland. So welcome, Alina. And lastly, it is my pleasure to introduce Dr. Shakes Chandra. Shakes' expertise includes image processing, AI and deep learning, image reconstruction, and medical image analysis. He received his PhD in theoretical physics from Monash University, and then he did a postdoc with a CSIRO in medical imaging. And he's developed machine learning algorithms for knee, hip, and shoulder joint segmentation for deployment on the Siemens Singo platform. And he's currently a senior lecturer here at the University of Queensland, and he leads a team of researchers working on image analysis and AI across healthcare and medicine. Welcome, Shakes. Welcome, everyone. We're really privileged to have you here. Thank you very much. And I'm going to be learning right along with everyone, and I can't wait. And I'll just jump right in if everyone is here. So to start things off, we have had a number of people asking the great starter question, what is deep learning? So that includes Clara, Jenny, and Jessica. And just want to also bring up this related question that we've gotten from John, and shout out to John Swinson. He's a legal expert that was one of our great panelists for Ask Me Anything about facial recognition. John's question is, how mature is deep learning, and are there deep learning commercial products available? So I wonder if I will stop sharing, and I wonder if we could start with you, Jeremy, to give us answer about what is deep learning, maybe some of the applications of it. And if you'd like to share your screen for this one, feel free if you want.
Sure. I also need permission to start my video from the home.
Okay. Let me. Oh, I can see it. Yep.
You can see my screen, but not my video.
Oh, your video. Okay.
Okay, I can make a start while you.
Yep. While I figure this out.
Hi, everybody. My name is Jeremy Howard. It's really nice to be here. I just thought I'd spend a couple of minutes giving you a brief taste of what artificial intelligence can do nowadays, and specifically the subfield of deep learning, which is responsible for nearly all of the breakthroughs you've been hearing about in the last few years. I think maybe the best way to see that is just to look at some examples. Perhaps some of the most kind of easy to understand examples of visual ones. So I thought I'd show you what happened when somebody on Twitter decided to basically copy and paste some of his friends' Twitter bios into something called DALL-E 2. DALL-E 2 is a image generation deep learning model. And so he got some of his friends' Twitter bios, which is this person's, which says, they're very strange bios, commitment, sympathetic, psychedelic, philosophical, and clicked generate. And these are the pictures that DALL-E 2 generated from that automatically. So here's some more examples of auto-generated pictures. This one is a bio that just had one word, book bear. Here's another one. Pretty amazing. And one more. It's pretty cool. Happy Sisyphus has created a smiling giant rock on somebody's back. So to be clear, you know, this model called DALL-E 2 was not in any way programmed to generate pictures from Twitter bios. It was just trained to recognize patterns that connect text to images. But the result of that is that you can auto-generate pictures like these ones. People sometimes complain that, well, this, you know, this isn't real, we're just kind of picking out the very best of them. To some extent that's true, but here's like an actual example of all the things that DALL-E 2 spits out. For example, for the text, expressive painting of a man shining rays of justice and transparency on a bluebird Twitter logo. And here's all the ones that it spits out. You know, none of them are garbage by any means. And it, you know, it does this in a few seconds. There are people now who take this a lot further by actually, you know, carefully constructing code, parameter tuning, prompt engineering, and so forth, and creating, you know, new artworks in this way, which I think is interesting. It's not just in vision. Deep learning can now explain itself. So here's an example of so the pink here is what the computer generated. So the human told it the question and the answer and asked the computer to generate an explanation. So you can read this one if you want to. So this was, again, this wasn't exactly coded to do this. It's just something that fills in text, but it can successfully fill in text, which is to describe things. Here's one where it's been asked to describe a joke. So this is a joke, not a particularly good joke, a joke about an AI joke about tensor processing units. And this model has successfully explained the joke. And you know, this is actually this actual English is the direct output of the model, to be clear. I'll show you one more example. So this model was asked, Shelley is from Virginia, but is visiting that city with the famous market where they throw the fish, going home next Tuesday. Question, is it likely that Shelley will be near the Pacific Ocean this weekend? And the model, again, it explains not just the answer is yes, but it explains its reasoning. The city with the famous market is Seattle, Washington. And I'm just pointing this out because a lot of people, you know, are under the impression that artificial intelligence is a kind of a black box that can't explain why it does what it does. But actually, it absolutely can do that. So hopefully that gives you a bit of a sense of where kind of AI is up to. The last thing I wanted to mention is this stuff is not just the domain of huge companies like Google and OpenAI. This is an article about a piece of work that me and my students did, showing that clever coders can still beat tech giants like Google and Intel, which was also covered in MIT Tech Review, where actually our small little group with a budget of about $100 actually built a very significant computer vision model that beat the world's best. And we did that just by using a bit of common sense, basically, and care. So there's a lot of exciting things we can do nowadays with AI, and actually AI is, really world-class results in AI is not out of the ability of individuals or small organizations to do.
Oh,
Yes.
still working on getting everyone's video.
I got mine. Thank
Oh,
you.
yeah, you're there. Oh, fantastic. Thank you for that. Thank you for that. Now, I guess our next question then might come from Saeed. What are the differences between conventional learning techniques and deep learning? And a related question from Sabah, when do we need to switch from other machine learning methods to deep learning? And does it only depend on the data we have? Maybe I will ask this one to you, Alina.
So I think that's an interesting problem. So basically the question is, when is deep learning suitable and when should we use traditional techniques? So I think, first of all, a lot of people like to use deep learning as a big hammer, that any problem, they want to use the tool that they know and apply it. And in some respects, it can work, but you also have to think whether you need to use that amount of computation for a task. I think in a lot of kind of tabular data, traditional machine learning methods actually work really, really well, especially the kind of gradient boosted type methods, XG boost, etc. But it's just, I guess, amazing that deep learning can actually be applied to almost any problem. So I don't know if Shakes or Jeremy would like to add to that.
I mean, I did just want to mention, like, we very often get excellent results with deep learning in under 10 seconds with under 50 records. Like there's no reason for it to take all the time, and not necessarily to take more time than tree-based methods. As Alina said, certainly sometimes on tabular data, there are some tabular data sets where tree-based methods can be more performant, although often an ensemble of tree-based methods and deep learning is better still. But we certainly shouldn't assume that a deep learning-based method will be slow or data inefficient.
Yeah, the only thing I can add is that, yeah, if you can do very basic linear regression, then you should probably stick to that. And if it's more complicated, then deep learning can provide, and most times does provide, an advantage.
Thank you. I've got a question from AP. AB, Shakes, go back to you. What are the biggest challenges in deep learning?
Yes. Okay. Well, I guess one of the main challenges I face, especially in the medical space, is labeling, high quality labeling. Although more methods have been developed now that you can do self-supervised or unsupervised learning. I think that's the next step. Used to be getting access to a GPU, especially during the pandemic, but that's going to be alleviated, I think. And I think it's more, yeah, for me, more high quality data. The data sets are getting very large. So another problem that I face personally is, how do you pump all that data through the models? You need high performance computing. So, those super clusters to push through, the entire data of the internet through to build your models. Do we have the infrastructure to build or to cope with those sorts of problems? Those are the immediate things that come to my mind. I don't know if others have any extra thoughts on that.
Yeah, I mean, I just wanted to, as I said before, we often get great results in under 10 seconds on less than 50 records with deep learning. So like, and the trick is to use transfer learning really effectively. It's not always possible, but it's normally possible. Yeah, the other thing to mention is, as Sheikh said about GPUs, you can get pretty high quality GPU time for free nowadays from Google Colab or Paperspace Gradient, and without any server setup or anything like that. So the hurdles to getting started and getting good results with deep learning have really come down.
Thanks. That's a fantastic segue to our next question. And also, just looking out, I'm realizing that because your video wasn't on, Jeremy, while you were doing that great introduction, there might be some confusion. Can Jeremy Howard raise your hand? So that, there we go, because they're both labeled as Shakes Chandra. So just
I see.
sure they know.
I can rename myself. There we go.
So everyone knows who you are. So we actually had quite a few people asking questions around the subject of how do we learn about deep learning. There's a lot of interest there. So I'm going to ask a few. Luckily, we have 3 experts in teaching about deep learning. So I'm going to ask a few of these questions here. Alberto had a question: how can I efficiently learn deep learning? So I, as the founder of Fast AI, maybe I'll start with you first, Jeremy, and then jump in from the
You might get a biased answer from me, Kate.
I think I'll jump to the 3 different perspectives on this one.
Yeah, I am quite fond of course.fast.ai, which is a set of free courses that covers everything from, the coding through to the math, through to the theory, or no charge. And I'll also say that the course that we run at the University of Queensland, Practical Deep Learning of Coders, I think is very good as well. It's not just me though. We've had, something like 6 million views now of our course materials. It's very popular around the world. And it's very easy to get started with. And we really focus on the kind of things I talked about of like freely available infrastructure and show you exactly how to use it. If you were not successful in getting into the course that we're running right now, the University of Queensland course, the whole thing will be also released for free on the internet in a couple of months. So keep an eye out for that. And there will be a part 2 towards the end of the year for people interested in pushing towards research level problems.
That's fantastic. Thank you. We are so happy to have you here teaching through the University of Queensland. Alina and Shakes, I know you're both also teaching here at the university. Do you have any extra sort of university perspective to add in?
So there's another related question that was posted in one of the pre-questions. So interestingly, when I was doing my PhD, deep learning hadn't actually resurged. So I started my PhD in 2010, and the big resurgence of deep learning was thanks to kind of now quite important paper, Alex Krzyzewski in 2012 kind of made deep learning kind of artificial neural networks possible again. So if you think about it, I personally didn't actually have an official training in deep learning in my university or even my PhD. So I think that these days there's actually a lot of really good online resources, and I actually love Jeremy's course. I think for practical deep learning, that's the fastest way, possibly where it comes from with the name, and I've heard that from many people as well. But I think you just really need to have an interest. There's tons of online resources, but I also think compared to just looking at any online resources, you need to balance that with theory, I think, as well. So I guess the difference between a machine learning practitioner and a machine learning researcher, it's not necessarily a complete distinction, but is that understanding when things go wrong. So I guess there's very, very, so someone who's only been looking at deep learning for maybe a couple of months might not know why something is happening. And so that's what takes a little bit of theoretical understanding, which can also be practical understanding.
And just to clarify, our course covers that in detail, and a lot of our alumni have gone on to publish papers at places like Europe's and get jobs at places like Tesla and OpenAI. So like you don't need, like, obviously university educations are great, but you don't necessarily need a PhD to
definitely.
be a
No, I
senior
agree
researcher.
with that.
You have just answered the question from Matthew, do I need a PhD? So here we have the answer. No. We have a great question from Ying Yi Shakes. Do you have any book or tutorial recommendations for beginners, and what level of statistics is required to get started?
Maybe I'm, repeating, plugging the Fast AI course. That's probably the best ways to start. In terms of statistics, I'm one of those people that believes that deep learning is something that can be interpreted as statistics, but isn't necessarily the best way to describe deep learning. But statistics is still probably necessary once you've done your analysis and tried to work out the significance of your results. And so basic statistics is quite important, I think, especially in understanding whether, you meet the scientific side of things or the reporting side of things, and making basic plots to justify your analysis. I may be, overstepping my bounds a bit by saying that you don't really need too much statistics for deep learning itself, but yeah, I'm happy to discuss.
Great. That takes care of Abraham's question.
And I think specifically the question was, what should they do before they start on deep learning? And I'd say,
What
like,
level of
regardless of
statistics?
Sheikh's answer there, I would say they don't need anything, like they don't need much before they start. Like I find a lot of people procrastinate actually building models for years as they learn everything about calculus and linear algebra and hypothesis testing and whatever. But it's not actually until you start studying deep learning and AI that you'll actually understand which of those parts you really need. And so doing it in a more need-driven way will save you years of time.
Excellent. Got a question from Joel, related but so different. How important is it to give the general population a basic understanding about machine learning and deep learning? And if it is important, how would we go about starting to do that? Alina?
So I think these days it's becoming much more prevalent in everyday life. So if you think about it, even if you have like a little, home assistant that you talk to, that's got some kind of deep learning in the background that's, doing the processing. Does everyone need to understand exactly what's going on? No, but for decisions that affect someone, I think it's important to be able to understand not necessarily the inner workings, but perhaps some kind of justification or some kind of assurance processes. And Caitlin, I know a lot of your research is actually around that. And I think as we progress more, we're going to have a lot more of the AI in our lives. So I think it's important to be able to, question these things. And so perhaps understanding some of the language is important. But does that mean understanding the inner workings? No, but that higher level and like the surrounding stuff around it, I think is definitely very important.
Yeah, if I could just add to that and say, 20 years ago, the concept of the app is kind of something that you wouldn't be that familiar with, but app is something that a developer would use, but now it's just a term that's widely used. And I think we'll see similar terms like that regarding deep learning. I'm not sure what those terms will be. AI is obviously already something that's being used, but I'm sure there'll be many terms like that that'll become common use that'll indicate the widespread nature of deep learning.
Great, thank you. And we have this sort of related question again, but different from Alam. Why are there so few postdoc positions in deep learning in Australia? You can take that literally, but then also I think it came to my mind, how is Australia performing sort of in deep learning space relative to what's happening globally? Jeremy?
I'm probably better to answer the second part of that because I've just spent the last 10 years of my life in San Francisco and Silicon Valley. So I'm not actually very on top at all of, the details of the scene here. But what I can say is, compared to the San Francisco Bay Area, deep learning here is a backwater. It's strange. Like it's not, you know, at Stanford, for example, you know, I think it's like their biggest undergraduate course is AI or subject. You know, as you kind of go to coffee shops and hang out with people and whatever, like deep learning and AI is just a really normal topic of conversation, and people have a high level of understanding of it on the whole. Amongst startup founders, the vast majority I would come across there would have a deep practical and technical understanding of deep learning and be using it in strategic ways as part of their startup. And I just don't see that here so much. And I spent 6 months studying why when I got back. And, you know, there's kind of deep structural and cultural problems, I think. And part of it is, you know, Australia is a very, you know, relatively speaking, hierarchical society. You know, we're very age-based in how we kind of handle things like seniority and opportunities in a way which I didn't see at all in California. And so, you know, as Alina mentioned, when, you know, for all of us as we were when we were going through our studies, none of these technologies existed. Now, some of us, including everybody on this call, nonetheless took the trouble to learn about them after the fact and try to generate that expertise. But I would say most people don't. And then, you know, if the most senior people are the people who therefore are the least competent because of their lack of training and work in this field, you have a problem, you know, because they're the ones supervising the PhDs and recommending topics. And I've actually noticed in Australia a lot of senior folks in academia, honestly speaking, not so much at UQ, but you know, you see it everywhere, are resentful and hostile towards deep learning in this kind of very emotional way. And I think it's because they're challenged by it, like they don't get it. And so their expertise is now not as meaningful as it used to be, and they do what they can to push back the day when they're obsolete. And I think it's bad for our students, honestly. And so when, yeah, you know, it's a hard thing to fix because there's so much emotion that kind of ends up in this like desperate need to stem the tide of technology so that your particular area of expertise becomes less, you know, relevant. So this is a big problem, you know, and I think we need to be, you know, promoting people in academia and elsewhere in Australia based on their capabilities and expertise, not based on how old they are. You know, I had lots of friends at Stanford and Berkeley and so forth who would basically go straight from their PhD within a year or two to being full professors because they were the best in the world at what they did, because nobody's done it for a lot more than 4 or 5 years because it's new, you know, and they would, you know, and similar people would end up as CEOs of big companies. That stuff's unheard of in Australia.
Does that echo your sort of perspectives? Feel free to just nod or jump in. Alina shakes.
Look, I think Jeremy's hit a lot of valid points, and that's something we're trying to change at UQ, and certainly that's something I've been pushing. We definitely need more AI at UQ, and that's what UQ itself through ITEE has been pushing through with the AI initiative. And yeah, that's definitely something we really need to address. I think deep learning will and does apply pretty much to every space. And if I would talk about my own experience, is exactly what Jeremy mentioned, was that you have to reinvent yourself because deep learning is so powerful and so revolutionary. And I had to do that in some respects to apply that to my area. You know, I'm very happy that I did. And I think that's sometimes very hard to do for well-established researchers, but also generally when the area moves so quickly, it's also hard to keep up. Yeah, look, I think definitely UQ and the university system, the system here in Australia, could do a lot more. And in terms of answering with regards to postdocs, I think you will see more and more come about. At the moment, I'd say they're more sort of in certain areas, so you might have to search a little bit. So you won't find necessarily deep learning direct appointments. I wholly agree we should have those. But you may find that you'd need deep learning in, say, medical imaging or in medicine or agriculture, and those positions are well and truly underway, and you'll see many of them launch in the coming 12 months or so.
I want to just echo what Jeremy and Shakes have said, but I think perhaps people are a little bit slow to adopt new technologies, especially here, perhaps because of being risk averse. So even if you think of our standards, so TGA, Therapeutical Goods Association, whatever it's called, which is the FDA equivalent, the process is literally get it approved in the States and Europe, and then we'll approve it in Australia. So like that's the way our model works. Perhaps it means that it's safer, I'm not sure, but it means that we've got a little bit of a lag from when technology becomes available to when it actually gets adopted. And so I just wanted to say that in terms of my observation, these days AI is sprouting out everywhere. So even though postdoc might not be in machine learning, I know a lot of people all across the university, from human movements through to medical through to agriculture, they all now want to use deep learning. So these skills are in high demand. Might not be a postdoc position, but definitely if people are interested, come talk to us. We're always interested in great talent.
I also wonder if our kind of funding model in Australia is part of the problem, because, like Australia genuinely had, and to some extent has, a world-class robotics area, partly thanks to a big ARC. But the funding model is such that at some point, after 5 years, it's done. So then what happens? Well, one of the key guys went off, quit academia, and started a startup because the ARC is done. And that's another part of the problem is our movement from research to commercialization in startups is not great, and so like he had huge struggles to do that. Literally, it wasn't UQ, but battling against his university, rather than having the full support of his university. So we've got a long way to go to, like, again, comparing to like what I saw at places like Berkeley and Stanford. Nearly everybody in a kind of deep learning or deep learning adjacent field, or almost most of the kind of software engine computer science professors as well, all had 2 or 3 startups that they had significant equity in, that their students had, built and they consulted to. And in Australia, at almost every university, that's extremely difficult to pull off because of the way our contracts are organized. And so I think we need to make structural changes to how that happens in the Australian academic system.
Thank you. Well, there you go, Alana. There's a bit of hope, some postdocs potentially coming down the pipeline. Okay, we have a lot of questions, people that are interested in deep learning in healthcare. So question from Graham about how deep learning is becoming increasingly used in healthcare research, but also questions from Lan, Katrina, Juliana, and Ian around, I think, because deep learning is being used increasingly in healthcare research, how important and how do we get healthcare providers to be skilled in the AI that they need? You all have expertise in these areas, but maybe I'll start with you, Shakes.
Yeah, sure. So this is also one of the, I guess, chalk up to one of the challenges of deep learning is the resistance we've had with regards to healthcare professionals not trusting AI technologies. And just asking what's the point, and that's one of the main issues we face, is to trying to convince I guess those who are in the health profession to kind of trust these things and really adopt these things. And that's one challenge. And I guess, you know, that's why some people do work in the explainability side of things, not because they think they need to explain it, but because sometimes users don't have the trust in it. And so that's one of the issues that we face. So what we try to do in healthcare at the moment is to provide a sort of have a human in the loop to convince professionals to continue to use it. So we end up providing feedback and automation, and that's primarily where I end up being part in. So we take away, or we try to, not take away, that's probably the wrong term. We try to improve workflows by automating as much of it as possible, so that clinicians can actually end up, you know, doing more patient care. And the areas that I've been involved in are sort of involved image analysis, where we automate mundane tasks, basically. And yeah, I'm not sure if I've answered the question or gone a bit off topic, but that's the kind of areas where we have AI in healthcare. And yeah.
And I guess this question around, thank you, Shakes. This question around should they be skilled in AI, I think also kind of links to a lot of the stuff you're working on, Alina, and a question by Xin Chen. How can we make explainable and interpretable deep learning? I guess sort of linked to it. I mean, if it's going to be used, for example, by healthcare providers, why is it so important, and how do we do it, Alina?
I personally think that explainable and interpretable models are important, especially in model development. So not just for the final, but like clinician or whoever's using it at the end, but for the designers as well. So currently, I would say deep learning is like a black box. Usually it's, you feed it an input, you get some output, and it's literally millions of parameters in between. And so in terms of people's trust in it, I think if they better understand what's going on and can actually sorry, my window's just disappeared, can verify that the outputs are correct, I think that is actually really important. So as an example, in a lot of models that have been released for chest x-rays, sometimes there's issues with the data sets. So for example, in one particular data set, what we call ground truth labels or correct answers for the disease has the people doing the labeling never actually looked at the images. And so that means that a lot of those labels were wrong. And so any model that you train off that produces wrong answers. Also, there might be spurious correlations in the data. As an example, let's say you're, again, taking chest x-rays of a patient. Turns out if you're too sick to move, you'll get a scan done on a portable scanner. And there's this big label on the image that says portable. So the machine learning model effectively cheats and will use that portable label and use that as part of its decision-making process, which is wrong. So in those cases, we can't simply just trust the output of a model, even if it gets something like 98, 99%. So I think especially when we're not at the stage where we're getting, perfect accuracy and using the right data, it's important to actually understand a little bit behind why a model has produced a particular output. So that could be things from highlighting what parts of the input are important, through to looking at the variables that contribute to a prediction. So some might be positively correlated or negatively correlated. And I think that helps in terms of understanding these models and improving them and making them more trustable for any end users.
Yeah,
Thanks.
just to quickly add, also now the FDA and some regulatory TGA regulatory bodies require, prior to approval, they actually require that you have evidence that the models are doing what they're supposed to be doing. And that's also part of the process, and also kind of is an important step. And finally, with respect to, I did mention that there's sort of difficulty to try to get professionals to use this. That idea is, of course, changing as more new professionals come through who have experience with AI. You know, they're younger, they have used these types of technologies more on a daily basis. And so it'll take time, unfortunately, but you know, those changes are going to happen, and that's what we have to look forward to. But unfortunately, it might take some time.
Thank you. And because we have a lot of interest in this healthcare space, we have a couple of questions around from Tim and Brett around how promising do you think AI is for drug discovery, and related to that about the DeepMind AlphaFold algorithm. Is that something that you might feel comfortable answering, Jeremy, around the application of deep learning in this space?
Sure. I'm more familiar in other parts of medicine than in drug discovery, but you know, from what I do know about drug discovery, yeah, I think it's very exciting opportunities there to dramatically speed up the process of drug discovery, to make it more accessible, to reduce hopefully the length of time that it takes to go through the process. Yeah, I mean, I just don't have the expertise to say to what degree better protein folding algorithms specifically help, but I certainly know of lots of other areas where drug discovery is progressing faster thanks to deep learning in terms of identifying, you know, the most likely molecules, or, you know, something I do find particularly interesting is like finding opportunities to use existing drugs. You know, there are some suggestions that we actually have pretty much all the drugs we need. There's certainly a lot of them. And it's just a case of identifying the places that we can use drugs that we already have. And yeah, these are all things, I mean, not necessarily deep learning for all of those things. Some of those things, you know, maybe other machine learning methods might be more appropriate. But certainly, generally speaking, I think machine learning is a big opportunity in that space.
And Elena, you mentioned black box. We have a question from Trung. Can deep learning be applied to deliver white box explanations? Anyone want to jump in?
Yeah, so I think these days we're opening up that black box a little bit, but you've also got the challenges of even understanding the explanations that they produce. So, you know, different explainability methods at the moment produce different answers because they're, you know, optimizing different objectives. So I think at the moment it's still a little bit of a young field. And so I think there's a lot of research that can still go into this. So I wouldn't say we're fully at the white box level, but perhaps that's a very challenging problem because even humans can't fully explain their decisions. So not always fully possible.
And one thing I just wanted to mention is something you mentioned earlier, Lena, is that deep learning is a black box because it has a lot of parameters. I actually tend to tell people, I do tell people, they should never be doing interpretability by looking at parameters for almost any model, or at least almost any model that's like complex enough to be giving people insights they couldn't have had anyway, regardless of whether it's a logistic regression model or a tree-based model or a deep learning model, because all real-world data has collinearity in it. You know, there are interactions there, there are nonlinearities there, and particularly in a more parametric model like a logistic regression, you're almost always going to have systematic model bias due to your, you know, inability to actually, you know, exactly match the kind of distributions and interactions and so forth. And so I actually find the view that, or the kind of a premise that interpretability is somehow better if there's less parameters isn't a correct premise. And so I actually think the kind of techniques that Alina's talking about for creating more of a white box around models is not just for deep learning. And I'd like to see them used for all kinds of models. And in general, the way I characterize them is by saying you should ask your models how they would respond to different situations. So for example, something that's a classic in the statistics literature goes way back is the partial regression plot, which is where we do exactly that. We basically, fill in a column with ones and then twos and then threes, and then we look at what happens to the output and we plot it. And that's a fantastic tool. And we can use that for logistic regression, for random forests, for GBM, for neural nets, for anything. Those are the kind of things which I think are really powerful. I would say neural nets gives us, which is the foundation of deep learning. I don't know if you agree with this, Alina, but I feel like they give us more tools than most of these other things do, because for three reasons. The first is they tend to be highly accurate. And as Bryman said in his classic Two Cultures of Statistics paper many decades ago, a more accurate model will give you more accurate explanations, all other things being equal. Secondly, they have gradients. And with gradients, we can much more quickly and correctly say what would happen if, and we can kind of create interesting artifacts from that. And then thirdly, we can do the kinds of things that you saw in my slides, where we can actually say to a language-based model, explain your reasoning, and it will reply in English. And I think those are all very interesting.
Thank you. And that is a perfect segue to get to your questions, Luke and Tim, around bias and how can we avoid deep learning perpetuating biases from historical data? Shakes?
Yeah, that's a very interesting question. There's been some recent work on trying to debias data or take an unbiased approach. So for example, I guess the answer is we need more techniques to do so. I'll give you the example that was published in a very big conference, an international conference called CVPR, Computer Vision and Pattern Recognition. And what they do is usually in skin-based research, most data sets are of Caucasians. And of course, we're lacking data sets for more brown, darker skins. And so the solution there is to create a model that is agnostic to skin shades, basically. And so they have image processing and deep learning techniques to try to account for that. And the goal is to be unbiased. And it is a problem because faces or sounds or other things are anthropomorphic, and they're based around how they've been acquired and what instrument they've used. And we face the same situation in healthcare where images are acquired from a particular vendor. So they have their own noise characteristics and other things that we have to deal with. And so, can we develop these new methods? And I think, maybe I'm dodging the question, but we need more techniques like that. Obviously, you could fix the data, but I don't know if we can always fix the data. And sometimes we have biases that we're not aware of. And so we need methods for those too. So yeah, hopefully that sort of addresses some of those questions, some of those parts of the question.
That's great. And I'm just realizing we're getting close to time. Abdul Majid, I didn't get to your live questions, but I can see if you didn't see, Shakes looked at that a bit in the chat. I'll just ask a final one to everyone from Robert and Anand combined. What gets you out of bed in the morning? What's the thing that excites you most about deep learning, or what's the future of deep learning? Alina?
I just think that the capabilities right now are really exciting. I mean, I love playing around with the deep learning models that come out. So that Dolly model that Jeremy showed at the start, I plugged our topic into that and put that on Twitter. It was a little bit worse than that. Yeah, I think just improving our understanding of deep learning models is the thing that I really want to do. So that's not necessarily just deep learning, but machine learning in general. So providing tools for us to be able to, better understand how these things work, because that's important for everyone.
Thanks. Shakes?
Yeah, so apologies to Hassan there. For me, it's knowledge discovery. So I don't really, I love how things are accurate. That's awesome. But I'm into the data-driven nature. So there is so much data that we humans can't look at it all and decipher what is good in it, what's worth exploring, and what is meaningful, and what should we look at. And what we're working on is basically taking, I guess one way to take away bias is to be data driven. So the traditional way of doing things is to go in, oh, I think the data would perform well, or these features would look good. And that's my opinion and my experience. But what deep learning can tell us is these are the good features, these are the good knowledge that's in the data that gives us the best either performance or interpretability or results, or all those sorts of things, or diagnosis. And that's what I'm excited to unleash onto the medical imaging side. Thanks.
Thanks. Jeremy?
I like the optimism of the framing of what are you so excited about that it gets you up. I'm not sure that's me though. I'm more what terrifies me so much that it gets me up in the morning. I'm terrified about the amount of kind of, increase of inequality that I feel a kind of status quo rollout of extremely powerful new technologies like this one create, particularly like when this one having more money and resources puts you in a position to get more out of it, which creates feedback loops, which we slightly problematically call positive feedback loops, but they're not positive in any societal sense. So that's actually why my wife and I created Fast AI is, quite a few years ago, we thought, everybody we know doing deep learning comes from one of 5 research labs, all of which are exclusive Western, nearly entirely American universities, and largely pretty much all white men, and we're from a very particular background. They're friends of ours. They're people we like. They're good folks, but they didn't have any knowledge of the real problems facing the world around, like, access to water or healthcare or whatever, so they focused on finding ways to better organize their iPhone photo collection and stuff like that. Yeah, so for me, increasing the accessibility of deep learning is a societally critical thing to do, and that's why I dedicate my life to that.
I couldn't agree more. Thank you for saying that. And there's a really great question from Michael here and around the AI alignment problem that we didn't get to, unfortunately, because I'm mindful that we're now at 4. I feel like we need to have a follow-up. Ask me anything to get to all the questions we didn't get, but I'm mindful that we're at 4. So thank you so much. That was a fantastic discussion. I'm really grateful for your time. Thank you, everyone here who's put in these great questions. I can see Shake's typing away, trying to answer as many as possible before I get to this close up. Type. Thank you so much, Jeremy, Alina, and Shakes, for sharing your expertise. Please make sure that you check out their web pages. They're doing amazing work. And stay tuned if you're interested to get our emails about upcoming events with the AI Collaboratory. So everyone, to use your applause buttons to thank our guests. Thank you so much.